All right, we're taking a look at solving linear systems by graphing. We're first going to jump into our vocab. We have a system of two linear equations, and that's when we have in two variables, x and y, and we'll also call this a linear system. It consists of two equations that can be written as ax plus by equals c and dx plus ey equals f, meaning we have two linear equations, hence the title, system of two linear equations. Now, our solution of a system is an ordered pair written as x comma y, once again in parentheses, that is true for both of the equations. So we'll get a point of intersection when we're graphing that will produce an ordered pair that's, when substituted back into both equations, will produce a true statement. Our first example, we have y equals x plus 2 and x equals negative 3. So we're going to graph the linear system and estimate the solution. So we'll be looking for their point of intersection. Now we're going to be graphing everything in slope-intercept form, so y equals mx plus b. Now the first equation is already in slope-intercept form. Our slope, the coefficient of x, is 1. We'll think of that as 1 over 1. And our y-intercept is at 2. So on a graph, we'll go up 2 units. And then to represent the slope, we'll go up 1 to the right 1. And we can also go down 1 to the left 1. We connect our dots, or ordered pairs, arrows at the end, and we have that equation graphed. Now the next equation, we have x equals negative 3. And just as a refresher, when x equals a number, we have a vertical line at that particular x value. So since x equals negative 3, we're going to have a vertical line at the x value negative 3, because no matter the y value, the x value will be negative 3. So we'll connect those. And then we can identify the point of intersection, so the point at which both lines cross over one another. In that ordered pair, start at the origin, we go left negative 3, or left 3 units, so negative 3, and then down 1 unit. So our solution is negative 3, negative 1. Now, one great thing with solving systems of linear systems, we can check our solutions. We can substitute negative 3 in for x and negative 1 in for y, and it should produce two true statements. If we get a true and a false, we have not found the solution, and we need to take a look back at our work. So for the first equation, y equals x plus 2, substitute negative 1 in for y, negative 3 in for x, and then we'll add 2 to that. So we're left with negative 1 equals negative 1, which is true, and the next equation, x equals negative 3, will just be using the x value of negative 3. So negative 3 equals negative 3. So it checks out. Now it's not required to check your solutions, but it's a good idea to verify that you have the correct answer. All right, our next problem we have 8x plus y equals negative 4 and 0 equals negative 4 minus y minus 8x. Once again, we're going to be writing everything in y equals mx plus b. So for the first linear equation, to isolate y, we're going to subtract 8x on both sides. So we'll be left with y equals negative 8x minus 4. So our y-intercept is negative 4. Our slope is negative 8 over 1. Now I can't go down 8 units, so I'm going to go up 1 unit, or up 8 units, excuse me, and then to the left 1 unit. Right. Connect our points, arrows at the end, and now we're going to rewrite the second linear equation. So if 0 equals negative 4 minus y minus 8x. Now we want to isolate the variable y, and we can do this by adding y to both sides. And so we're left with y equals, and I'm going to use our symmetric, or excuse me, I'm going to use the commutative property here and just write this as negative 8x minus 4. Once again, to graph that line, I'll go down 4 units and then up 8 units to the left one. So that will be represented in the red equation. Now, if we take a look here, the blue and the red line, they are the same line. We can tell that since they are the same equation, they're going to be the same line. So every single point, these lines are touching. So they have infinitely many solutions. So we'll say infinitely solutions, and we'll use the infinity sign to represent that. So infinity solutions. There are infinitely many solutions that are true for both of these equations. If one solution is true for one, it's going to be true for the other, since they're the same exact line, given by the same exact equation. All right, third. All right, so we're going to graph the linear system and estimate the solution. Alright, so our first equation, we have 7x plus 2y equals negative 6. We'll write that in y-intercept or slope-intercept form. So we'll subtract 7x from both sides. We're left with 2y equals negative 7x minus 6. And then we'll divide both sides by 2. So we're left with y equals negative 7/2 x minus 3. So our y-intercept is negative 3. And then we'll go down 7 units to the right 2. Or we can go up 7 units to the left 2. Connect those. Arrows at the end. And then we're going to write our second equation, negative 14x minus 4y equals negative 2 in slope-intercept form. So we'll add 14x to both sides. We're left with negative 4y equals 14x minus 2. Then we'll divide both sides by negative 4. So we are left with y equals 14 over negative 4, simplifies down to negative 7/2 x. And that will be plus 1/2. So we'll go up 1/2, and then we'll go up 7 units to the left 2, and then we also can go down 7 units to the right 2. Alright, now let's take a look at these lines. These lines are parallel, meaning they will never intersect. So we have no solution here. There's no ordered pair that will be true, that will produce a true statement for one equation that will also be a true statement for the other. Now we can not only tell that they're parallel based on the graph, but also by their slope. Since they have the same slope, they're going to be parallel. So there's another indicator right away that you will have no solution for this particular linear system. Alright, let's jump into a word problem. So we're told a math quiz is to have 5 questions. The quiz format uses multiple choice, worth 1 point each, and problem-solving questions are worth 2 points each. The test has a total of 7 points. So first we have to write a system of equations to determine how many of each type of questions are used. When we're writing equations, we always want to define the variables. So I'm going to say x equals the number of multiple choice questions, and y equals the number of problem-solving questions. Once again, defining your variables allow you to write equations more quickly and also know what your equations mean. So the first thing we know is we're going to have 5 questions on that quiz. So the number of multiple choice problems plus the number of problem-solving questions equals 5. And then we can take a look at the total value of the points. So the test has a total of 7 points. So each multiple choice question is worth 1 point, so 1x plus 2y is going to equal 7. Now since x, we can write 1x just as x because there's an understood 1, we can look at it as that way. So this is our linear system. For B, we're asked to solve the system by graphing, so we need to write these in slope-intercept form. Our first equation will subtract x from both sides, so we'll get y equals negative x plus 5. So y-intercept 5, slope of down 1 over 1, or up 1 to the left 1. Connect our ordered pairs. And then our next equation, we'll subtract x from both sides. We're left with 2y equals negative x plus 7, and divide both sides by 2. So we're left with y equals negative 1/2 x plus, and we're going to think of that as 3.5 since we're graphing that y-intercept. So we're going to go in between 3 and 4, and we'll go down 1 unit to the right 2, down 1 unit to the right 2, and so on. Alright, so it's represented in red. So our point of intersection appears to be at the ordered pair 3, 2. Now once again we can check this. So x value 3, y value 2, 3 plus 2, it does in fact equal 5. And then we have 3 plus 2 times 2 equals 7, or 2 times 2, excuse me. So 3 plus 4 equals 7, which is true as well. So that's our solution. Now since it's a word problem, we want to express our answer in terms of words. So we can say the test has 3 multiple choice questions and 2 problem-solving questions. All right, so that finishes out for tonight. Keep in mind your project is due Monday. Hope you have a great weekend, and I will see you soon.